Hey there, Josh here from Limble CMS, and today I'll be talking about troubleshooting and the techniques to fix devices and equipment. Be it at home, at your office, or at manufacturing plant, devices we use are bound to malfunction at some point. When rebooting the system doesn't solve the problem, we or a technician have to test other hypotheses to identify and fix the issue. That is troubleshooting in a nutshell. If you work in the maintenance department of a facility, you know how much money can be involved in replacing or repairing some assets. So if you can troubleshoot effectively, it not only saves money for the company, but also helps to avoid friction with the finance department. And in this video, I'll cover what troubleshooting is, some of the common causes, and different ways to troubleshoot while streamlining the process for the future using your CMS. But before jumping into all that, make sure you're subscribed to Limble's YouTube channel to receive a notification whenever we post more videos just like this one. So what is troubleshooting? Troubleshooting is a step-by-step approach to find the root cause of an issue and deciding the best way to fix it to get it back in operation. Troubleshooting is not just for equipment that has completely broken down. We also use it when a machine is just not working as expected. And efficient troubleshooting is an essential part of asset management, diagnosis, and repair. Let's go ahead and take a look at when it's the right time to troubleshoot and why. Broadly speaking, it's done when there's either a device failure, an unexpected operation, or other anomalies. Device failure is the big one. It's the most urgent reason to troubleshoot. A broken machine can have a knock-on effect in a company by putting everything on hold. That can easily cost hundreds of thousands of dollars per minute. Having a capable maintenance team that knows how to troubleshoot effectively and use a CMS troubleshooting checklist can reduce high severity outages and save the company money. Situations of unexpected operation are not as urgent as a total failure, but still should be taken seriously before a real issue comes up. Take the cooling fans in your plant, for example. Imagine they are running and pushing out cool air, but every so often they stop blowing for a few minutes or the air isn't as cold as it should be. Other equipment might overheat because of that malfunction and eventually start to break down. Fixing a fan as soon as you know about it will save the company time and a lot of money. Getting operational users to log faults when they come up can be a great way to get the problems early and avoid total failure. Using the CMS system to log the problem also gives teams a written history of what happened and how it was fixed, making troubleshooting time in the future that much easier. And by other anomalies, I mean a strange sound, a weird smell, visible smoke, excessive vibration. So the machine is working within the ideal operating range and is delivering the expected output, but an operator has spotted something different going on. Such anomalies should also be investigated within an appropriate time window to avoid costly repairs in the future. Now let's go more in depth on the benefits of troubleshooting. Reactive maintenance and a lack of troubleshooting know-how costs a lot of money, but you already know that. What we don't always consider is that these costs go beyond pure dollars and cents. Unplanned dollars that go into repairing broken and faulty equipment often cause the finance team to be up in arms and get them wondering why maintenance is so costly. Being able to troubleshoot well and having all the information at your fingertips gives leverage to reframe the conversation and relationship with them. And instead of finance coming to you and wondering why everything you need costs so much money, you can simply say, hey, look at how much we've saved you. This could have cost you hundreds, if not thousands of more dollars. Now, as far as finance is concerned, you're the hero instead of the villain. Another benefit of effective troubleshooting is decreasing downtime. Downtime is expensive, often more expensive than just the cost of fixing the machine. In a study by GE Digital for ServiceMax, surveying 450 services and IT decision makers from around the world, they found that of the 82% of companies that have experienced unplanned downtime over the past 3 years, those outages lasted an average of 4 hours and cost an average of $2 million. They also found that unplanned downtime results in loss of customer trust and productivity. 46% couldn't deliver services to customers, 37% lost production time on a critical asset, and 29% were totally unable to service or support specific equipment or assets. That, of course, affects your reputation. Continued breakdowns and halts in production can lead to a lack of trust from your team and customers. If your company can't guarantee delivery of products and services, your customers will go to someone who can. The same applies to employees. When they cannot do their jobs because the equipment they need doesn't work and they cannot get help, their morale is affected. But when you've got a maintenance crew that's effective at troubleshooting with a great system to back them up, they uphold your company's reputation, which helps drive brand loyalty. And that's a great solution for the replace or repair dilemma. Sometimes repairing equipment isn't worth it. It isn't always easy to ask the finance department to shell out money for new equipment, especially if it wasn't part of the original budget. By tracking maintenance and repairs in a CMS with functioning reporting, you can produce factual information about the planned and unplanned maintenance, cost, frequency of breakdown, and loss of productivity of an asset. So the cost of replacement is justified. But who performs troubleshooting? Often the most experienced technicians are the ones doing the troubleshooting. Unfortunately, 60% of these maintenance professionals are retiring in the coming few years. What makes these technicians so good at what they do? Well, many of them have learned through trial and error what are the best troubleshooting techniques for each piece of equipment. And there is massive value in having those senior technicians running through the troubleshooting teams and creating checklists that hit on the most common issues. The problem here is that when all these experienced technicians retire, they take their knowledge with them. So to avoid losing valuable historical info, it's extremely important to codify the information to a central hub like Limble. And when that happens, any technician can look at the entire work history of the asset, and users can also add notes and quirks about the machine that would usually take a lot of trial and error to uncover. And this, in turn, saves a ton of time. And depending on the complexity of the machine, your maintenance crew can train experienced users for straightforward troubleshooting tasks. And all the info, such as work order, maintenance history, checklist, manuals, lives inside of Limble CMS, which significantly speeds up the troubleshooting process. Troubleshooting is a step-by-step process. So now I'll go ahead and break it down into 6 simple to follow steps so you can understand it in a clear manner. As we go through them, keep in mind that it doesn't matter if you are an advanced or inexperienced professional. You will follow the same systematic approach every time. So step 1, define the problem. When looking at a problem, you need to know what you are up against and the possible causes. Is it a total machine failure, an unexpected operation, user error, or a random anomaly? What happened that alerted you to the problem? Some equipment will have built-in ways of letting you know. Alarms can sound, red lights flash, or a warning can go off when certain parts overheat. Other equipment simply just stops working. Whatever the case may be, a clear definition is fundamental when troubleshooting. In step 2, you want to collect relevant information. You need to gather all the available information about the machine and its operations. That includes the machine manual, maintenance history, problem reports, and any data regarding operations. For example, how often the machine is used, by whom, for what, and how long. A modern CMS like Limble should have the option to keep a digital copy of all these documents. In step 3, analyze collected data. Using all the information you have gathered, available checklists, and as much technical know-how as you can gather as well, you can now try to determine the root cause of the problem. So seek out expertise from other maintenance troubleshooters or the person who reported the fault. It's much easier to solve a problem that you have seen before. And think about recent changes to the asset. You should ask yourself questions such as, has there been an upgrade lately? Has the device been used in a different way than usual? Recent changes to the system or environment can often explain why the problem has come up. If you still have no clue what caused the problem after analyzing the data, you need to go back to step 2 and collect more info. In step 4, propose a solution and test it. Using the insights from the data you analyzed, you can create your own plan of attack. You'll get to the solution through a process of elimination and trial and error. You may have multiple options to try. Start with the simplest one first and work from there. Remember to take into account the potential safety concerns, all the required resources, associated costs, how complex the implementation will be, and any personal biases the person performing the troubleshooting may have. And make sure to keep testing until you are sure that you have found the right solution. And if nothing works, you'll need to rethink what the actual cause is. In step 5, implement the solution. Once you have diagnosed the problem, found the solution, and tested it, it's time to get your hands dirty and simply fix it. Make sure the asset is working the way it should before you pack up and sign off. In step 6, document the process. It sounds obvious, but it's crucial to document the solution and add it to the asset log in your CMS. It's easy to get carried away working and forget to document your findings. I'll do it next time, you might think. But what if you don't? And what if it simply just gets lost into oblivion? Or maybe you're on vacation next time. So as you're going through the process, take the time to document everything properly. Troubleshooting can easily feel overwhelming and disorganized when it's not approached with the right tools and strategy. Let's go ahead and take a look at a few of the commonly used resources for effective troubleshooting. Troubleshooting checklists are a great way to approach common problems methodically and help standardize the process. So whenever a problem comes up, any trained technician can use a checklist to complete the troubleshooting process. These are also helpful when you have to go through the process yourself. When you've got a lot going on, it can be risky to rely on your own brain to remember all the steps. And having a checklist means that you don't have to. And having an experienced team is also key to making your life easier. Keep in mind that when you use a modern software and data is being tracked, technicians and machine operators don't always necessarily need to use their years of experience. They just need to know how to leverage existing data and pre-made checklists. So to make that happen, you must have the right CMMS at hand. A modern CMMS can automate your maintenance operations and save your team's time and your company's money. As a centralized repository of maintenance data, a CMMS keeps a lot of helpful information used during the troubleshooting process, like OEM manuals, contact information for machine and parts vendors, maintenance logs and reports, details of the work requests sent to report the problem, and of course, troubleshooting checklist. Now let's go ahead and take a look at the future of troubleshooting. With factories becoming more automated, machines need fewer operators. Because of that, the number of technicians required for troubleshooting and equipment maintenance is growing. Luckily, technology is also making troubleshooting easier, faster, and less dangerous. Let's go through some solutions that are making their way to many plant floors. We have machine learning. In the context of troubleshooting, machine learning helps us analyze large amounts of data and predict possible causes of failures. And some organizations are already taking things a step further and testing something called prescriptive analytics, which aims to help machines diagnose themselves and then present possible solutions based on that self-diagnosis. Pretty cool, right? Another solution you might have seen around is augmented reality. In plant floors, it combines computer-generated imagery with the actual equipment to give an additional layer of information. So holding a phone or tablet over the machine, the program pulls up all the different layers of information for the technician to look at. Now this is an easy, fast, and safe way to check if everything is where it should be. And we have simulations and virtual reality. VR takes you into a world of endless possibilities as you are whisked into a simulated environment of the machine you are working on. In this virtual environment, expensive equipment can't get damaged and you can't get hurt. It's a great way to learn, play, experiment, and practice before having to return to the real world to fix the actual machine. And techs can have 100% immersive experience fixing things. It's like turning the job into a video game. It's a digital twin, a virtual copy of your machine. Sensors installed on the machine send data about its condition and performance. The cloud-based copy analyzes this data that's coming from dozens or hundreds of different production floors that all use the same type of machine, and it uses it to advance technology, predict failures, and also find ways to repair problems from a distance. If a failure happens at your location, the OEM can compare it against the data from all other machines of the same kind. And based on this analysis, the OEM can identify it if a similar incident happened to a machine at some other plant and propose a potential solution. In the best case scenario, a malfunctioning device will result in a mild annoyance. And in the worst case scenario, it can cause a safety incident and have a debilitating effect on a business's bottom line. It's crucial to be prepared to deal with any situation. Being able to quickly deal with equipment issues is ultimately a reflection upon the maintenance department in its entirety and how well it was able to organize, work, and train its employees. Since skills and experience are so important, businesses should make an extra effort to reduce the turnover of experienced technicians and operators. If you'd like to start it right with a modern CMMS, feel free to start Limble's free trial. I'll leave the link on the video description. Also, if you enjoyed this video, make sure to like the video and subscribe to our channel, and that way you can keep up to date with everything maintenance. With that said, I'll go ahead and see you in some of our following videos. Cheers.